Okay, this is the second of our videos on SAT Math Prep, speed and accuracy. So we're going to go through some sample SAT questions and look at how to solve them. So the first question is, in the XY plane, the point 3, 6 lies on a graph of a function f of x equals 3x squared minus bx plus 12. What is the value of b? So here, you've been given the value of x, which is the number 3, and the value of f of x, right, which is the 6. All right, let's change the color. Okay, so we have 3 and 6. So here, all you do is go in and substitute. So when we have f of 3, right, wherever you see x, substitute 3, right? So it's going to be 3, and then we have 3 squared minus b times 3. So we can simply write here 3b. All right, plus 12. So that's the 12 here. So this is the second term. This one is what we have here. And we've been told that f of 3 is equal to 6, right? This value here is going to go here. So 6 equals 3, and then 3 squared here becomes 9. So 3 times 9 minus 3b plus 12. All right. So here, let's try and solve this equation for b. So this is a simple algebra, right? So here we have, we try and bring this negative 3b to the left and then send 6 to the right. And like I've mentioned in the past, anytime you cross the equal to sign, the sign in front of you changes. So it becomes 3b. And then we have 3 times 9 is what? 27. On the right, we already have our 12, which is this one. And this 6 is going to cross over. Over here, it's a plus. When it crosses over, it becomes a minus, right? This is the method of doing, simple algebra or basic algebra by using the system I called like terms together, right? You just put like terms together and solve the equation, right? You could also have gone the method of, subtracting, adding to the size of the equation and going forward. So here, let's continue. So it's 3b equals 27 plus 12 minus 6 is going to be 6. So it's 27 plus 6 is 33. Right? And then the b is going to be what? 11. All you have to do is divide each side by 3. 3 cancels 3. That's 1. 3 goes into 33 is 11. So the value of b is 11. All right? So that's for the first question. Our second question, it's also about a function. So it says f satisfy f of 2 equals 3 and f of 3 equals 5. A function g satisfy g of 3 equals 2 and g of 5 equals 6. What is the value of f of g of 3? Here you see they've given you a lot of information, but you don't have to be, too concerned about it. All you have to know is, if you have, let's say, a function f of x equals, say, 2x plus 5, right? Anytime the x changes, it affects the overall value, right? So let's say if you put f of 1 here, right, it means every x you see on the right hand side becomes 1. So this will become 2 times 1 plus 5, right? So when you say f of 1 equals 7, that's basically how they arrived at it. But this is beside the point. This is just to, highlight why they have this. So let's try and solve the equation itself. It is not an equation, it's just a couple of values given us. So it says f of 2 is 3, f of 3 is 5. The main concern is this. So let's focus on this. So it says f of g of 3. So let's find if we know g of 3, right? G of 3 is what? 2, right? So we have f of g of 3. In place of g of 3, we put 2, right? Similar to what we did here. Wherever we see x, we put the value given. So wherever we see g of 3, we put its value. So that's the value, 2. That's what I've inserted here, right? And then we look through what is given. Here we see that anytime you see f of 2, it's 3, right? So this question is done, right? We are done. Don't worry about any of the other information given. It's redundant information. Somebody may find use for it and, spend a lot of time trying to complicate things. But this is the answer, right? So our answer is B. Okay, let's go to the next question. Question number 3. Here you have a circle, and then you've been given this coordinate on the circle, right? So this is a circle in the XY plane, which the question clearly states, right? And we've been given this. Here, the easiest way to solve this is to remember the reference page that they give you on the exam, right? They give you a reference page which has diagrams, some formulas, some shapes. So spend time whilst you're preparing. Occasionally look at that page, right? Look for a sample SAT test. You can get one, on the internet, and then look at the sample reference page and see the guide over there, right? So you're familiar with what you're going to encounter, right? So it's not going to be the first time that, okay, you spend some minutes trying to look at, okay, what do they have on the reference page? Look at it whilst you're preparing so you are aware. That's the essence of preparing for an exam, like the SAT, right? You should have a fair idea what you're going to be asked, right? And what aid they are giving you. So here, if 2 of them look like this. And if you look through, you will notice that here they're referring to this angle here. It says in the XY plane, O is the center of the circle, and the measure of angle AOB. The angle is always in the middle, so it's AOB. So they're referring to this angle, right? And then it's looking like this. It's not really a straight line, right? But look at this as a triangle within the circle, because that's the only way you can get this angle here, right, to relate to this. So looking at this, here we have x and then x square root of 3. So x over x divided by square root of 3 is basically what is given here, right? Because the tangent of this angle is what this is about, right? So it's what? Rise, which is 1, over run, which is square root of 3. So this is basically, you know, the tangent of whatever angle is here, right? So the tangent of, let's say, angle z degrees, right, is what we're finding, right? So from here, all you have to do is look, what angle gives us this tangent? It's 30 degrees angle, right? It's this angle here, which is 30 degrees. So 30 degrees is equivalent to what we've been given here, right? It's equivalent to the 1 square root of 3, right? But we are more interested in the angle itself, right? The angle itself has been given. So remember, this angle here is what has been given over here at the point O, right? So basically, they want you to convert the 30 degrees into radians, and in the process, find the value of A. So in circles, right, the total angle, if you go around the circle, is 360, right? So 360 degrees, right? And that happens to be 2 pi radians. Right? I'm putting 3 marks here to mean equivalent to, right? Not exactly equal to, it's equivalent to, because these are 2 different units, right? So if this is true, then what will 30 degrees be in radians? Because in the end, our 30 degrees radians is going to be pi over A, right? So if this is, if 360 degrees is 2 pi radians, then what is 30 degrees? So it's going to be basically 30 over 360 times 2 pi, right? This is just ratio, right? So let me put this here. This is question mark radians. So that's what we're trying to find, right? And this basically gives us, this is 1 over 12, and then 2 divides. So let me do 1 here, 12 here, and then 2, 2. So this becomes pi over 6 radians, right? So this is for our 30 degrees. So basically what it's saying is the pi over A given in the question is equal to, remember, this is now equal to this pi over 6. So from here, we can see that A is equal to 6, right? So the value of A is equal to 6. That's all they need us to do, right? So let's go to the next question. Question number 4. All right, question number 4 says it's a system of equations, right? With one of the equations having A and B coefficients, right? And they are constants. And then it says if the system has infinitely many solutions, right? We should find A over B, right? Because it's a system of equations, you should be able to solve and get solutions, right? So here, all you need to be concerned about is if these two have solutions. Solutions means simply that they meet at a point, right? Or they meet at certain points. They can be lying on each other, right? If you have two lines sitting right on top of each other, it means they're meeting indefinitely, right? They just keep all points on all the lines are the same continuously, right? So here we're going to find A over B. So the way you deal with this is if these two are going to be, giving us a solution which is, infinite, then it means that if we can make any part of the equation to be equal, meaning visibly equal, here what I would like to do is multiply the first equation by what? 5. So that in the end, I will end up with 60 on the right-hand side, right? So what does this become? This becomes 5ax plus 5by equals 60 on the right-hand side. And then I leave the second equation alone. Second equation is 2x plus 8y equals 60. So here I have 60 and 60, right? And if these two are giving me the same solutions, right, infinitely, it means that whatever the coefficient of x here in the first equation has to be the same. So everything about their coefficients too have to be the same, because the x doesn't change, the y doesn't change. That's the variable. So here all you have to do is, equate the coefficients to each other, right? X for x and y for y, right? And I'm talking about the coefficients here. So I would say 5a equals 2, right? That's for these two. 5a here equals 2 in the second. And then in the same manner, I would say 5b equals 8, right? 5b is the coefficient in the first equation. 8 is the coefficient of y in the second equation. And then they want me to find a over b. Nothing complicated. So what I do is I take the left side and divide. So I say 5a divided by 5b. Let me erase this. So I say 5a over 5b is equal to, and then I divide the right hand side, 2 over 8, right? On the left hand side, I have 5 in the numerator and denominator, so that cancels out. 5 divided by 5 is 1. And then on the right hand side, I can simplify. 2 in the numerator, 2 goes into 8 is 4. So in the end, my answer is going to be a over b equals 1 over 4. All right? So that's how you handle a question like this, right? Try to bring it to a point where you see the similarities clearly. From there, you should be able to deal with it. From there, you just have to worry about comparing the coefficients, right? And that's done. Sometimes they will flip the question around and you have to compare, instead of the coefficient, maybe one coefficient and then the constant here. But in either way, in either case, it's the same approach. All right, let's look at question number 5. Question number 5 says, which of the following is equivalent to the sum of the expression? So the keyword is sum, right? And here we're going to add these two, right? Because we are not subtracting, I wouldn't worry about parentheses that much. You guys keep hearing me mention parentheses, right? Parenthesize as you go. Because it's a sum, I can just, do a squared minus 1 plus a plus 1, right? You can even do it visually, right? So here I see a squared minus 1, and then I see another plus 1. So minus 1 plus 1 is what? It's 0. So I'll end up with a squared. So let me cross this out. This crosses out. A squared plus a. So our answer is a, right? This is very simple. Let's move on to question number 6. All right, question number 6, we have an equation, and we've been given one of the values. We want to find k, right? Here you notice that k is under a square root sign. So ultimately you have to get rid of the square root sign before you can get your k value out of the equation. So you just use the information given and start to work on the question. So we have k plus 2. Both of them are under the square root sign, so you have to watch it. Minus x is equal to 0. All right? We've been given the value of x, so we just substitute and see what happens. So square root of k plus 2 minus 9 equals 0. All right. So from here, what we do is we bring this 9 to the right-hand side. Or you can use your system of, add 9 here and add it on the right-hand side. It's the same thing. I call it like terms together, right? So square root of k plus 2 equals 9. Now, to get rid of the square root sign, what do? You have to square it. Whatever you do on the left side of the equation, do the same thing on the right side. So I square the left side, I have to square the right side immediately, right? So the square sign releases the square root. It's gone now. On the right-hand side, what do we have? 9 squared is what? 81. This is a simple algebra equation, right? Now we can just solve. So we have, on the left, we have k. If you subtract 2 from either side, the right-hand side is going to be 81 minus 2, right? And 81 minus 2 is what? 79. And our answer is here. It's always nice when you work out the equation and you get your answer in there. Some people prefer substitution, but sometimes substitution can waste time, right? Because you may not find the value immediately. You start from the top, substitute 1, substitute 7, 16. That can waste your time. If you know what to do, just do it, right? And skip substitution or elimination. Okay, so question number 7. All right, so question number 7, we have this quadratic equation to solve, right? So this quadratic equation has two solutions. Once again, we have solutions, right? If it's a quadratic function, they will say, zeros or solutions or roots, right? So remember those terms. Solutions, roots, zeros. They are all the same, right? Put them on your index card somewhere, right, as you prepare. All right, so here I look at this, and the first thing I would like to do is simplify the equation by dividing by 4, because I can see that 4 is a factor, right? So I can rewrite this equation as what? X squared minus 2x minus 3 equals 0. All right? From here, those who like substituting to try to eliminate, you can, it's easy to substitute now. But I would prefer to solve it, right? With quadratic, there are, a couple of ways, at least 4 different ways to solve the equation and get your answer. You can use the quadratic formula. You can use, the product sum. You can use complete the squares. And then, there's a third method. But here, we're going to try to use the product sum approach. In that approach, you multiply the coefficient of x squared by the constant c, right? So the general equation looks like this: is ax squared plus bx plus c equals 0, right? So we're going to multiply the coefficient of x squared, which is currently 1, by the constant c, which is minus 3, right? So we have, let me write it somewhere. We have minus 3, right? The second step is to find 2 factors of this product, which is the minus 3, such that when you add them together, it's going to be equal to the coefficient of b. I mean, the coefficient of x, which is the b here, right? So let me repeat. First, you multiply the coefficient of x squared by the constant c. We got minus 3. And then you find 2 factors of minus 3 that when you add together will give you minus 2, which is the coefficient of x, right? Here, our 2 coefficients are what? We can have minus 3 and what? 1. These are the only 2 coefficients. These are the only 2 factors of minus 3, which when you add together will give you minus 2. So with that in mind, we try to rewrite the 2x so that it will contain these 2. They call it decomposition, right? So just rewrite it so that in the end, when you combine what you've written, it gives you minus 2x. So here I start with my x squared, right? And then I would say this is a plus. This is a positive 1. So I would say plus x, right? And then minus 3x, right? So these 2 are from here. I'm just decomposing the b term, right? The second term. And then I continue by writing my minus 3 equals 0. All right? So let me carve this out. So it's out of the way. So this equation is the same equation we've rewritten as this by using the method I just mentioned, right? And then you have to continue to group these and factor out. These are already grouped, right? That's what you do when you write in this. Make sure you write it in such a way that you don't have to do another step of regrouping and then before you factor. So here, we try to factor because we have common factors between these pairs, right? So in the first two, our common factor is x. Now in the parentheses, we have x plus 1. In the second pair, we have minus 3. It's factored out. And then it remains x here. And remember, because it's minus 3, what is inside here becomes plus 1, right? The reason being, when you try to expand it, you have to get back the minus 3, right? And this is the only way. So when you're doing something like this, you can easily test, right? Factorization and, distribution. You can test it immediately by looking at it. So that's what we've done. And then we look at what we have. We see x plus 1 is common, so we can factor it out, right? So we put x plus 1 out, and then we bring our parentheses. What is remaining on the left is what? X. What is remaining on the right here is what? Minus 3 is equal to 0, right? So our two factors are what? X plus 1 and x minus 3. Now the solutions are what? Because this is equal to 0, what can make this 0? This can become 0 when either x plus 1 is equal to 0, because if you multiply this as a 0 to this, whatever this is, it's going to make the whole thing 0. Or x minus 3 is equal to 0. I'm stressing this because it's very important. Once you get this concept, you will be able to deal with, the difference between factors and solutions, because it's the reverse of the other, right? So if this is true, then this is, a simple algebra we can solve. It means x is equal to minus 1, right? Remember, we got this from here, so you can reverse it. This is what we call root or solution or 0, right? What I have on the left-hand side is what we call factor, right? And it's actually coming from here, these two. All right, I hope I'm not confusing you. This is important to get. Once you get this, you will begin to love functions, right? And then the second one says x is equal to 3, right? So we look through our answers. X minus 1, this is not true. X minus 1, 3, this is true. X minus 1, so this is B is the correct answer, right? So with this, we've learned a couple of things. We've learned that solutions, roots, zeros, they mean the same thing, right? And the method of, using the product sum, right? In future, there'll be similar questions to, or if you find quadratic equations, try and apply the same approach that we used, and it comes out, nicely. You don't have to stick to this formula. For me, it's easy, it's straightforward, right? If this is not possible, you can use, the quadratic formula, or you can use, completing square. to do it, and you should arrive at the same answer. All right. And also know the difference between a factor. Anytime you hear factor, think multiple. If you hear solution, think an actual value, right? Okay, so let's move on. Question number 8. This is a circle, right? And, anytime you have a question, look at it and then see what is given. I'm sure a lot of people know this sign. This sign means right angle, right? If you see this sign, it's right angle, which is equivalent to 90 degrees, right? In radians, this is going to be pi over 2. Because like I mentioned in the other question, we know 360 degrees is equivalent to 2 pi, right? So 180 degrees will be equivalent to pi. So 90 degrees will be equivalent to pi over 2. And you can keep going, right? If you want to create an index and, have something to memorize to be able to speed up on the test, you can do this. But this is beside the point. I'm bringing this up because we're preparing for an SAT. The more we know, the better, right? So here we see this. The total internal angle in the circle is 360 degrees. That's the first thing we need to know, right? And that's 360 degrees is covering the circumference and is covering the area. In other words, they are equivalent or proportional. That's the correct term, proportional, right? This is just additional information for you, right? So when you see circles and they want you to find an arc, just use ratio. If the whole circumference is equivalent to 360, then the arc is equivalent to a certain angle given. So here, all we know is the 90 degrees is a fourth of the 360, right? So it says the circle above with center O has a circumference of 36. What is the length of the arc AC? So the minor arc AC, this is what they're referring to, right? Since the angle divides the whole circle into 4 parts, then what we can infer is this is just a fourth of the total. So it's what? 36 divided by 4, which is 9. So here's our answer. I know I gave you extra information, but they are all important, right? Because, it's an exam preparation. If you get additional information, you can apply it somewhere, or maybe you don't know it yet, you can put it on your index, revisit the video, check it out again. You can, ask questions after you review the video. All right, so we go to question number 9. Okay, question number 9. Here we have a graph, right? Now, here we need to be careful. Look for the axis. Y-axis is here. X-axis is here. So the origin is going to be here, right? If you're not careful, you would think the origin is here because of the location of the letter O. But look for the axis. Where do they cross? They cross over here, right? So with that in mind, we see this line, right, is increasing, right, to the right. So the slope is going to be positive. Slope, which is M, is equal to what? rise over run. Over here, rise over run is what? 1 over 1. So slope is 1, right? It's 1 over 1, right? Wherever you take it, if you take it from here, it's supposed to be the same, right? So it's going to be, if let's say I took it from here, it's going to be 1, 2, 3, 4, 5. That's the rise. And then 1, 2, 3, 4, 5, right? Remember, you have to land on the line. Okay. So it says, which of the following is an equation of a line L in the XY plane, right? We know the general equation of a line is what? Y is equal to what? Mx plus b, right? In this, we know m. So can write y is equal to 1 times x. So that will be x plus b, right? And then we know the intercepts, right? One intercept is 0, 1. The other one is what? Minus 1, 0, right? We can substitute any of them. So I'm going to use this intercept. Remember, the intercept has 2 coordinates, right? 0, because it hasn't moved on the x-axis, and then 1, because it rose 1 time on the x-axis. So 0 and then 1. So we substitute this in this equation and find the value of b. But normally, the intercept is going to be b, right? The intercept on the y-axis is going to be b, right? Unless, something else is happening with the equation. So let's just substitute and then move on. So wherever we see x, we put 0. Wherever we see y, we put 1. So 1 is equal to 0 plus b. So b is equal to 1. So we substitute in this. We got y is equal to x plus 1. So D is our answer, right? And just a few points. We know it's not going to be this because x is equal to 1, right? It's basically saying that we're moving vertically like this. We moved here and then nothing else happened, right? X is constantly 1, independent of what the value of y, we don't care. So y is moving from infinity to infinity, whereas x is equal to 1, right? Same thing applies here. Y is equal to 1 means we moved here and then we stayed there, right? So it's a straight line which is parallel to the x-axis, right? So, you can, play around with these. And y is equal to x is basically a line going through the origin, right? Okay, so let's move on to question number 10. All right, so here we've been given which of the following is an example of a function whose graph in the xy plane has no x-intercepts, right? Has no x-intercepts, right? X-intercept means it should cross the x-axis. If it has no x-intercept, it means it's wavering around, either on top or below the x-axis. Okay, so A linear functions whose rate of change is not 0, right? If these say this, because the rate of change is what? Basically the slope, right? So if you have a linear function whose slope is not 0, then it's either going to be this or that, right? Rising upwards or falling downwards, right? If you have the xy plane like this. So this is not true, right? So we say cancel this out. A quadratic function with real zeros, right? But the question says there are no intercepts. Intercepts, zeros, solutions, roots, they are all related. So it can't be this. A quadratic function with no real zeros, right? Like I just mentioned, no real zeros, no intercepts, they are going to be the same. Let's check the last one. A cubic polynomial with at least one because the question says there are no intercepts. So if it has one, if it's rising, if it's doing anything other than, not having solutions, then it's not true. So there we have it. All right. Let's move on to 11. All right, so let's look at question number 11. It says y is equal to x squared, and then 2y plus 6 equals 2 in brackets x plus 3, right? So here we have to substitute for y in the second equation. They want us to find x times y. We'll be given a condition that x is greater than 0. So let's do the substitution. So if I substitute y, in place of y, I put x squared plus 6 equals 2x plus 3, right? So let's do 2x squared plus 6. With I movement, you notice that 2 is going to multiply 3, so we're going to get 6 somewhere on the right. So we have 2x plus 6, right? So with this, we know that these two will cancel out, right? Canceling out meaning that, it's going to be 0 eventually. Either you bring from the left to the right or from the right to the left. 6 will cancel out, become 0. And then we're going to end up with 2x squared equals 2x. Here too, we know we can divide by 2, right? We can actually divide by 2x, the left, and then 2x on the right. It says x is greater than 0, so that's why we can divide by the x term here. So 2x squared divided by 2x will leave us x. And then 2x divided by 2x will leave us 1. So x is equal to 1. All right? So that's our answer. Our answer is A. So sometimes the question will look a little complex, but once you start doing it, you get your answer. Right here, I forgot to mention that we're looking for x times y, but we notice that y squared is equal to, y is equal to x squared. Y is equal to x squared, right? So if you substitute 1 for x, y is equal to 1 as well. So if you multiply x and y, it's 1 times 1. All right? Question number 12. All right, so for question number 12, we have a squared plus b squared is equal to Z and AB is equal to Y, which of the following is equivalent to 4Z plus 8Y? So basically, we're going to substitute for Z and Y. And whenever you read the equation, just do a quick scan at the answers. The answers are going to be in terms of A and B, right? So let's do our substitution. So we have 4. In place of Z, we're going to put A squared plus B squared. And then plus what? 8. In place of Y, we're going to put AB. So let's expand this. 4A squared plus 4B squared plus 8AB. All right, and then we can rearrange it so to get a better view. So 4A squared plus 8AB plus 4B squared. So we notice from here that 4A squared can be written as what? 2A all squared, right? And also 4B squared can be written as 2B all squared. And then over here we have our plus 8AB plus 2B squared, right? The reason I'm writing it like this is to be able to see how this relates to our regular equation. A squared plus 2AB plus B squared, right? Which comes from A plus B all squared, right? The way the expansion happens is you have A squared, the first term squared, multiplied by 2 times the terms in the brackets. So 2AB, which is this, and then plus the second term squared. So we look at this, right? And we can infer from this that if we write 2A, right, plus 2B, and then we square it, it's going to be equal to this, right? Let's check and see. 2A squared is going to be this, right? And then 2B squared is going to be this. And then we have 2 times 2A times 2B. So 2 times 2 times 2 is what? 8. And then A times B is what? AB. That's this one, right? So we look through the answers. We know for sure that A is not correct. B is the answer. If we are even to guess, right? We know from here that if you square 4A, it's not going to be, come back to 4A squared. It's going to be 16A squared. Same thing applies here. So that eliminates C and D right away. But this is the approach to solving this. And try and remember this formula, right? And how it comes about. Okay, so question number 13 says, Jackie has 2 summer jobs. She works as a tutor, which pays $12 per hour, and she works as a lifeguard, which pays $9.50 per hour. She can work no more than 20 hours per week, but she wants to earn at least $220 per week. Which of the following system of inequalities represents this situation in terms of X and Y, where X is the number of hours she tutors and Y is the number of hours she works as a lifeguard, right? So when you're doing this, be careful with the hours, which one they apply to. The X applies to tutoring, and the Y applies to the number of hours worked as a lifeguard. So let's go through. Here we have keywords. It says no more than 20 hours, right? It means if you combine the hours worked tutoring and hours worked doing lifeguard work, it should be no more than 20 hours. So it should be less than or equal to 20, right? So it's going to be X plus Y is less than or equal to 20. So we just look through quickly and see which one we can eliminate. We know we can eliminate this because we're aiming at less than or equal to 20. We hold on to this for now, right? We hold on to the C also. We can eliminate this, right? So we are down to 2 answers. And then we continue to the next information. Jackie wants to earn at least $220 per week. So it's going to be at least $220, right? So between these two, right, we just look through. That eliminates this. So this is our answer, right? But when you're doing these questions, be careful with the information. Sometimes they'll, mix up the X and Y, right? So make sure they are doing this one is easy because they arrange them the same way, right? But just be careful. But you just have to look at the conditions given and then note them down and quickly go through. A question like this shouldn't take you long. Maximum 1 minute, you're done. Okay, let's move on to 14. Question number 14 says the volume of a right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? So there's a cylinder, right? Cylinder is like, a kind of tin tomato or, a kind of milk, right? So we're talking about volume. As I mentioned in one of the questions on the exam, they give you aid or reference page where they have shapes or figures with formulas, right? Just to help you, right? Instead of you going to the exam and then flipping in back and forth, whilst you're preparing, take a look at the page. You can get a sample page from the internet and then start looking at it. You don't have to memorize all these formulas. If you know them, it's good. I'm sure those heading to engineering, they have these things down, right? Because it speeds up what you're working with, right? So here we are talking volume, right? A is just the cylinder, right? So we're talking 2 volumes that we're comparing. Let me call the first one volume 1, second one volume 2, right? It tells us that the volume 1 is what? 22 cubic centimeters, right? So let's write 22. But we know we get that through this formula. And the formula says pi r squared times the height, right? The radius is, let's see this, and then the height is here, right? Just like they've indicated. So this is the first volume. Second volume, we don't know yet, but we should know the formula based on the information given. Now, let's pay attention to this. We know pi is a constant. There's nothing to do with that. And then it says the radius, right, is what? Twice that of the original cylinder A, right? So here, this is where you have to be careful. You know the general formula says pi r squared h. So here, I'm going to reference this radius. So I'm going to say it's 2 times the original radius, right? That's what I've written here. But we know we have to square it. And then the height now is what? Half. So I take this, divide by 2. You can put it in parentheses. But this is what is most important to me, right? You pay attention to this. Always start from the general formula and what the information is inferring and apply it accordingly, right? I've seen students where they will just write 2 r squared, and forget that the 2 is also being squared because the radius has now changed. All right, let's move on. So after you write the second volume, you just rearrange and see how it relates to the first, right? So here I'll have pi 4 times r squared times h over 2. 4 because the 2 squared, right? Now I can simplify. 2 into 2 is 1. 2 into 4 is what? 2. So on this side, I will have what? Pi times 2 times r squared times h, right? If I rearrange this, it becomes 2. I bring 2 out, right? For convenience, pi r squared h. Now, the reason I did that was I'm trying to look for how this relates to what I have here. And it's clear that I get twice the volume. Remember, this number here, this was what? 22. So wherever I see this whole thing, I can just drop 22. So we did all this just to say that the answer is 44. These questions are interesting questions. If you are able to work multiple examples, you're going to like it, right? Just step by step, right? Don't rush it. Just put 2 volumes or 2 areas or whatever the question is asking about, and base it on the general formula. Start from the general formula and then work your way down, right? Good. Let's go to the next question. Question number 15. All right, this is a question on indices, right? So we have 9 raised to the power 3 over 4. We want to see which one of these is equivalent, right? So what I would do, there are a lot of ways people may approach this, but what I would do, I will rewrite this as 9 1/4 times 9 raised to the power 1 over 4 times 9 raised to the power 1 over 4. Why am I doing this? Because I know 9 is a perfect square, and I see the 4 here. If I can do something to get a square root of 9, that will help me a lot. So right away, from the first two, right, from these two, I can see that I have what? 9 raised to the power half, right? Because 1/4 plus 1/4 is 2/4, which is half. And I'm saying plus because in indices, one of the rules is, using the common base, the indices, they add up, right? The powers add up. So that's how I got this. Multiply by this one here, which is 9/1/4. And I know that square root of 9 raised to the power half is the same as square root of 9, right? So remember that. If you need to put it on an index card, do it. If you raise a number to the power half, it's equivalent to finding the square root, right? So what I'm saying is the same as square root of a, right? So here I have 3 multiplied by 9 raised to the power 1/4. And if you are in a hurry, you don't even have to continue. You look at your answers. Sometimes it's good when you working, you take a quick scan at the answers, and then you start the work. So I see a 3 here. It got to be this, right? None of them has a 3 as a whole number. So I can use this to save time and move on. But if I need to continue, I just will say 3 multiplied by, and then for 9, I will say, okay, I have half raised to the power another half. When you have the index like this, the powers are multiplying, right? That's different from what I did initially, where the powers added, right? Here, I want to reestablish 1/4, right? By rewriting the term with the two different powers, right? That's why I put the parentheses. And I already know I have 3 here, right? Multiply by this one in the parentheses becomes what? 3. But remember, it's still being raised to the power half, right? And like I mentioned here, anything you raise to power half is the same as square root. So basically, this becomes 3 square root of 3. So our answer was correct, right? So go through this a couple of times and you'll get it. And then learn your indices, right? Learn the rules of indices. Number 16. Okay. This is a system of equations we're supposed to solve. Here, the easiest way is to substitute for y in the first equation from the second. So we go half brackets 2x plus, in place of y, we put 2x. That's what is here. It's equal to 21/2, right? For those of you who know this, if you see these two denominators, they basically cancel out. Or if you can take the usual steps, you multiply the right hand side by 2, left hand side by 2, right hand side by 2. So this cancels out. And then in the parentheses, we have 4x. On the right hand side, we have 21. So x is equal to 21 over 4. Or you could have, continued by adding these two, multiplying by half. And then eventually, if you divide, the 2 comes down and you get the same thing. All right, so let's go to question number 17. Right? Question number 17 is simple. We just simplify this as an algebra and solve it. So we have the first term becomes 2p plus 2 plus, we distribute 8 over. So 8p minus 8 is equal to 5p. Right? And then you can use the idea of like terms together. I want to bring all the p's to the left and all non-p's to the right. Okay, so I count the number of terms. Here I can simplify, already, but let's just group the terms. So we have 2p plus 8p, and then 2p plus 8p on the left minus 5p. And then on the right, I move the 8 over 8. And then I move the 2 over minus 2. Remember, when you cross the equal to sign, the sign in front of you changes. That's why 5p becomes minus 5p. And then minus 8 became 8, plus 2 became minus 2. Right? So from here, this is 10p minus 5p. That will be 5p. And then we have 8 minus 2, that is 6. So p is equal to 6 over 5. We get here by just dividing the left side by 5 and the right side by 5 so that the p can stand alone. All right, let's go to question number 18. Question number 18. It looks complex, but it's simple, right? Basically, you have two fractions. Even though it has x terms in it, it says we want to have this expression written equivalent to this, and then in the end find the value of a, right? So if you look at the two denominators, the way you establish the common denominator is you just have to multiply the right one by what? Itself, to get it squared. If you do that in the denominator, you have to repeat it in the numerator. So we have 2x plus 6 over x plus 2 all squared on the left side. And then on the right hand side, we have x plus 2, right? I put it in brackets because I'm going to, square it just for, visibility, right? And then on the top, I already had 2. I multiplied by x plus 2, right? This 2 is the same as this, right? So let's focus on the numerator. So make a long line, put x plus 2 squared, and then on top I have 2x plus 6. And remember, this minus affects everything here. So I'm going to expand with minus 2, right? So it's going to be minus 2x minus 4. All right. Now, nicely, we notice that 2x minus 2x cancels out. It's 0, just as they said, right? If you get anything else, it means you did something wrong because they gave you a as a positive constant, right? So if the x doesn't go away, it means you're already on the wrong path. And then we have 6 minus 4, which is equal to what? 2. So we have 2 over x plus 2 squared, right? And this, they say, is equivalent to or equal to this, right? So what is our a? A is equal to 2. All right. Let's go to question number 19. All right. Question number 19 is with angles, right? There are a couple of ways you can solve this. So with angles, you have to look for a few things, like, you know, the angle they're looking for. Is it part of a triangle? Is it part of, a shape which is in X, right? Or a Z? Or is it, part of a right angle, right? So a few things. So here we see a triangle in here, right? We see this triangle. Right? So one way to solve this is we can find the angle here and then the angle here. Once we know this angle, we can subtract it from 180 because x is on a straight line with this angle, right? And angles on a straight line total to 180 degrees. Total angle in a triangle is what? 180 degrees. On another straight line is what? 180 degrees. So let's use that approach. So to find the angle here, let me call it angle A, right? Angle A is equal to 180 minus 106, right? And this is going to be 74 degrees. So this angle here is 74 degrees. Right? And like I mentioned, the total angle here within the triangle, because this forms a triangle, right? So let's say this angle is B, right? To get the angle B, we have to find the sum of these two and subtract it from 180. So we get 74 degrees plus 23 degrees, which is equal to 97 degrees. And then we subtract that from 180. 180 minus 97 degrees is equal to what? This is 3. And I think we got 70. It's 83, right? Yeah, it's 83. Okay. So B here is now 83. And to get the x, right? Because x is on a straight line with the 83, our x degrees, or we can say x plus 83 is equal to 180 degrees, right? So x is equal to 180 minus 83, right? Which ends up becoming 97 degrees, right? And you notice we've taken a series of steps, right? We had 97 degrees here, and we ended up with 97 degrees here. So there's a method of doing this where if there's a triangle and one of the sides is extending, right, to form an angle outside, we call it exterior angle with one of the existing sides, right? If you add the two angles, right, which are opposite the exterior angle, they're supposed to be the same. What do I mean by this? It means x here is the same as the angle at this corner, which is 74 plus the 23, right? This you have to practice, draw a bunch of triangles, put some angles, lose some of the angles, and then with practice you see this, right? Even though there's a rule for it, you don't need to know the rule by by visualization. You should know, right? So if that what I'm saying is correct, then these two angles, right? If you add these two angles, 83 and 23, it should also give you 106, right? So we could have done this in a few, maybe 2 steps, by first finding the angle here and then adding it to 23, and we got the 97 degrees outside here, right? So go through and you realize that this is the fact. One other way we could have done, if we know how to apply this formula, I could have said that this angle, because I have a straight line, I would say 180 minus x, right? This angle, right? When I add it to 23, should give me what? 106. And if you solve this, x is going to give you 97 degrees. So like I said, there are several ways to do this. You just have to understand and know how to deal with angles, right? When it comes to questions with angles, you start by looking for an X shape, right? Look for Z, right? Look for a straight line. Is it a triangle? Is it part of a triangle? Is it, part of a 90-degree angle? Right? So there are a few things you have to look at, but it all comes with practice, right? Okay, let's tackle our last question. So question number 20. It says at a restaurant, n cups of tea are made by adding tea bags to hot water. If T is equal to n plus 2, how many additional tea bags are needed to make each additional cup of tea? Right? So we have T cup of tea is equal to n tea bags, and then there's a constant 2, right? So anytime this changes, this is supposed to change, right? So this is the beginning. And then let's say we have a condition where we want to find, let's say, T, let me put, X here. It's equal to, and then they say the number of bags has increased by 1, right? So this has increased by 1. Remember, this is the n, which has increased. Our 2 is always there. 2 is always a constant, right? So let's find out what's going on. So t subscript x is now equal to what? N plus 1 plus 2, right? Now let's try and compare this with the original equation. We see n here, we see n there, we see 2 there. So if we combine n plus 2, we're going to get tx equals t, which is n plus 2 plus 1, right? So what this tells us is that anytime the number of tea bags increases by 1, the number of cups goes up by 1, right? So our answer is B. All right. So go through, practice, and ask questions. All right. Thank you for listening in.